Okay, in this activity, a sporting goods manufacturer claims that the variance of the strength in a certain fishing line is 15.9. A random sample of 15 fishing line spools has a variance of 21.8. At an alpha of 0.05, is there enough evidence to reject the manufacturer's claim? So we are given the variance here. That's why our 15.9 does not have a unit measure. So let's keep that in mind. We've got the variance. And really here, we're just testing, to see, can this manufacturer make this claim? So we're not testing, is it greater or is it less than? We just want to know, is it equal to that? So with 95% confidence. So our null hypothesis is that our population variance is equal to 15.9. That's the claim. Our alternative is that our population variance is not 15.9. So we have a confidence level of 95%. Our alpha is 0.05. This is a two-tailed event. Our sample size is 15 and our degrees of freedom is 14. So from the chi-square distribution, we're going to find that the critical values are 5.629 and 26.119. Now I want you to keep in mind that this is a two-tailed event because it is the not equal sign here. But we're going to be taking this alpha of 0.05 and splitting that into the two tails. So half of 0.05 is 0.025 in either tail. So we need to look at two different columns in our chi-square distribution. So I'm going to go to that. Our chi-square distribution, the right one's a piece of cake because we're looking for 0.025 in that right tail. Now the left side we'd be using this column here is chi-squared 0.975 because again this chart is set up to give you the probability of the area to the right of this column. So this would be the column that would show 0.975 area to the right. That means there would be 0.225 or 0.025 to the left. So we're going to go this down to our degrees of freedom was 14, and so we have 5.629 here in this column. So that's going to be the critical value that separates our left tail rejection zone from the usual. And then over here in this column, 0.025, we're down to 26.119, the value that would separate our right tail rejection zone from the usual values in the middle of our curve. So I'm going to go back to this. When we set up to do our test statistic, it is our degrees of freedom times our sample variance divided by the population variance. Now they were giving us variance. It's already there. I don't need to square anything. So these are both variances. This is the sample. This is the population variance. When I plug all this in, I get a test statistic of 19.195, which looks like it would fall between these two things. What that looks like on our curve is I'm going to have my 5.629 marking off my left tail, and I have the 26.119 marking off my right tail, and the 19.195 is in the middle between these two. It's not in the rejection zone, so we're probably going to stick with our null hypothesis. The p-value and the confidence interval, actually I worked out the formula for the confidence interval on this one, but I'll go ahead and do it on StatCrunch as well along with the p-value. So when I go into StatCrunch, again I'm going to go to Stats, Variance Statistics, One Sample with Summary. Again, I need to put in my sample variance, which in this case was 21.8, and our sample size was 15. We're doing a hypothesis test. We're saying that sample or the population variance is 15.9. And we're going to leave this as is because we're just testing to see if it's not that. So I go ahead and hit compute, and I come up with our, let's just slide this over here a little bit. Came up with our test statistic and our p-value of 0.3153. If I want to go in and do my confidence interval, I'm going to go and leave the variance and the sample size as is. I'm going to come down here and click on the confidence interval. Now again, we had an alpha of 0.05 in a two-tailed test which happens to coincide with this, that our default here is 0.95 for a confidence interval, which is a two-tailed event. So we're all good to go. We can go ahead and click compute. We end up with, our confidence interval. The lower limit is 11.7 and the upper limit is 54.2, which is what they came up with here. I can close that down. Now this is in variance form, which is what our problem is in, and our null hypothesis is set up in variance as well. So we can leave that as is. We can see that our population variance, the claim that we're testing, 15.9, falls in that interval. Because that claim falls in the interval, we can't reject the null hypothesis. So all three of these, this here, the p-value is high, so the null must fly. All three of these support that we cannot reject the null hypothesis, so we fail to reject the null hypothesis. There is evidence to support the manufacturer's claim that he can safely say the variance in the strength is 15.9 for this fishing line.